Consider 80 grams, 80.0 grams of a sample of two different compounds, and that compound only consists of carbon and oxygen. One of the compounds has 21.8 grams of carbon, and the other one has 34.3 grams of carbon. What's the ratio in whole numbers of the masses of carbon that combine with 1 gram of oxygen? So this is John Dalton's law of multiple proportions. And if you've done a couple of these, you probably already know that this is going to be carbon monoxide and carbon dioxide. But we're gonna work this out, show our work here, so we get the concept down. All right, so for compound, let's say this is compound 1 here in blue. All right, we're given that we have 80 grams of both. All right, so for compound 1, which is going to be carbon monoxide. Anyway, excuse me, you're not supposed to know that, so let's just say compound 1. Compound 1. All right, so we have 21.8 grams of carbon to a ratio of 80 minus 21.8 grams, because that's going to give us the oxygen part, right? Because if the whole thing is 80, there's only two elements. If 21.8 is carbon, then the rest of it must be oxygen. Okay, so we're going to get this ratio, and let me get my calculator. Okay, 21.8 divided by parentheses 80 minus 21.8, close parentheses, enter. What? Oh, what? Okay, hold on, do that again. I don't know why it multiplied. I don't remember hitting that. So 21.8 divided by parentheses 80 minus 21.8, close parentheses. I must have hit the wrong key. All right, so that is the ratio in that first compound. So 0.375 is good enough. 0.375. Right, is how many grams of carbon we have per grams of oxygen. That's the rate. It wanted us to know per gram of oxygen. So this is 1 per 1 gram of oxygen. All right, so let's do the same thing here with compound number 2. Let's do this in green. Where's that number? All right, here's compound number 2. All right, still. All right, so we got 34.3 grams of that compound is carbon. And we know that the total sample is 80. And because there's only one other element in this compound, which is oxygen, we can say 80 minus the 34.3 grams is going to be the oxygen component. All right, I got to pause here. I'll be right back. All right, where was I? Special guest, pay me a visit. Oh, right. Let me get my calculator. All right, so 34.3 divided by parentheses 80 minus 34.3, close parentheses. All right, so let's go 0.751. 0.751. All right, so compound, the second compound, 0.751 grams of carbon per 1 gram of oxygen. Now, we're just going to get the ratios of the masses of carbon. That's what it's asking us to do. determine the ratios of the masses of carbon. Oh, excuse me. All right, let's put the bigger number on the top because then we'll get a whole number. All right, 0.751 over 0.375. Just taking these numbers, putting the bigger one on the top so we get a whole number, and I bet you that's going to be 2 because, like we already said, we've done this problem already a few times, and this one is going to be, compound 1 is going to be, Dalton didn't know this, but we know it's carbon monoxide, and compound 2 is carbon dioxide. But anyway, the question is asking us the ratio is going to be 2 to 1 between compound 1 and compound 2. So 2 to 1. And there's our answer.